Good afternoon, students. Let's continue our discussion on differentiation. Let us have a look at our next question, which is question number 41. If f of x is equal to g of x plus g of minus x by 2 plus 2 by h of x plus h of minus x whole power minus 1, where g and h are differentiable functions, then f dash of 0 is equal to. Okay. So, f of x is equal to g of 1 by 2 into, I will write it as 1 by 2 into g of x plus g of minus x plus 2 divided by h of x plus h of minus x whole power minus 1. You take it to numerator, it will be 2 into h of x plus h of minus x. Now, differentiate this with respect to x. F dash of x, that is equal to 1 by 2 into derivative of g of x is g dash of x, derivative of g of minus x is g dash of minus x into minus 1 plus 2 into derivative of this is h dash of x plus derivative of h of minus x is h dash of minus x into minus 1. We are asked to find out f dash of 0. So, put x equal to 0. When I put x equal to 0, we are going to get 1 by 2 into g dash of 0 minus g dash of minus 0. Minus 0 is same as plus 0 plus 2 into h dash of 0 minus h dash of 0. So, everything gets cancelled, hence the answer is 0. F dash of 0 is equal to 0, which is the second option. Then 42nd question. If f of x plus y is equal to f of x into f of y and f of x is equal to 1 plus x into g of x into h of x, where limit extends to 0, g of x is equal to 2 and limit extends to 0, h of x is equal to 3, then f dash of x is equal to. Okay. See, they have given that f of x plus y is equal to f of x into f of y. And what is f of x? F of x is 1 plus x into g of x into h of x. What about f of 0? F of 0 is equal to 1 plus 0 into all this, it is 0. So, f of 0 is equal to 1. Here you observe f of x plus y is equal to f of x into f of y and f of 0 is equal to 1. Then for f dash of x, there is a direct formula. What is that formula? F dash of x is equal to f of x into f dash of 0, which you have seen in our previous class. This is a formula. When f of x plus y equal to f of x into f of y and f of 0 is equal to 1, then you can write f dash of x as f of x into f dash of 0. Okay. So, now f of x is 1 plus x into g of x into h of x. F of x is equal to 1 plus x into g of x into h of x. Differentiate this. Let us see what is f dash of x. That is equal, I have to use product rule here. It is a product of three functions, x into g of x into derivative of h of x, which is h dash of x, plus g of x into h of x into derivative of x, which is 1, plus x into h of x into derivative of g of x, which is g dash of x. This is f dash of x. What is f dash of 0? F dash of 0 is equal to, this term will be 0 plus g of 0 into h of 0 plus that will also be 0. G of 0 into h of 0. Observe here, they have given limit extends to 0, g of x equal to 2. Limit extends to 0, g of x equal to 2, that is nothing but g of 0. So, g of 0 is equal to 2 and h of 0, limit extends to 0, h of x equal to 3, that is nothing but h of 0. So, h of 0 is equal to 3, hence f dash of 0 is equal to 6. So, the answer will be f of x into f dash of 0, which means 6 into f of x. So, 6 f of x, that is the fourth option. Then 43rd question. Let f and g be two differentiable functions satisfying g dash of a is equal to 2, g of a is equal to b and f circle g, f composition g is identity, then f dash of b is equal to. Okay, given g dash of a is equal to 2, g of a is equal to b. then f circle G is equal to identity. F circle G is identity, means f of g of x is equal to x. F circle G equal to identity means f of g of x is equal to x. Now differentiate this. So when I differentiate it, f dash of g of x into g dash of x is equal to 1. F dash of g of x into g dash of x equal to 1. Now here I will put x equal to a. Putting x equal to a, we will get f dash of g of a into g dash of a is equal to 1. So f dash of g of a, what is g of a? B, into g dash of a is 2 is equal to 1. So from here I can write f dash of b is equal to 1 by 2. F dash of b is 1 by 2, which means the first option. Then 44th question. If y is equal to x by a plus x by b plus x by a plus x by b plus etc. up to infinity, then dy by dx is equal to. So here you have, observe here, y is equal to x by a plus x by b plus x by a plus x by b plus etc. It continues in that way. Now if I remove this much, starting from here, you have x by a plus x by b plus x by a plus x by b plus etc. It continues in that way. So if I remove this, still this much, this expression can be written as y. Observe, x by a plus x by b plus x by a plus x by b plus etc. It continues in that way up to infinity. So this much can be written as y. So here you have y is equal to x divided by a plus x divided by b plus y. X divided by a plus x divided by b plus y. So y is equal to x by, take LCM here, LCM is b plus y. This numerator will become ab plus ay plus x. This will go up. So y is equal to x into b plus y. I can write that as bx plus xy divided by ab plus ay plus x. Cross multiply. So when I cross multiply it, I am going to get aby plus ay square plus xy is equal to, on RHS what do you have? Bx plus xy. So this xy gets cancelled. Now you have aby plus ay square equal to bx. Let us differentiate this. On differentiating this with respect to x, we get aby y dash plus 2ay into y dash is equal to b. Take y dash as common, y dash into ab plus 2ay is equal to b. Hence y dash equal to b by, I will take a as common factor here, a into b plus 2y. Y dash is equal to b by a into b plus 2y. b by a into b plus 2y, which is the second option. Next, 46th question. If x is less than 1, then 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 etc. up to infinity. X is less than 1, then 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 etc. up to infinity. Here they have not asked us to differentiate it. They have asked us to find the value of this expression. That's all. This is not of CET standard. This is well above CET level. Okay. Anyway, I will explain what to do. I will tell you. You look at 1 minus x into 1 plus x. What is 1 minus x into 1 plus x? That is equal to 1 minus x square. Right? Then what about 1 minus x into 1 plus x into 1 plus x square? this is equal to 1 minus x square into 1 plus x square, it will become 1 minus x power 4. Then 1 minus x into 1 plus x into 1 plus x square into 1 plus x power 4. That will give you 1 minus x power 8. Okay? Then 1 minus x into 1 plus x into 1 plus x square 1 plus x power 4 into 1 plus x power 8. We can write that as 1 minus x power 16, because this much is 1 minus x power 8 into 1 plus x power 8. Together it will become 1 minus x power 16. Okay? Now you consider this. 1 minus x 1 plus x into 1 plus x square etc. up to 1 plus, let us say 1 plus x power n is even. Then we can write this as 1 minus x power 2n. Here you observe, when x power 1 here x square, when you have last term as 1 plus x square, here 1 minus x power 4, here 1 plus x power 4 is there, so this will become 1 minus x power 8. When x power 8 is there, x power 16, x power n is there, means x power 2n. Okay? But here this n is tending to infinity. Why? Because up to infinity we want. So when you have n product here, product of n factors, then this expression will be equal to 1 minus x power 2n. Now what I will do is, I will take this n to infinity. That means there are infinitely many terms. As n tends to infinity, what will happen to x power 2n? Power tends to infinity and this fraction, this base x is less than 1. So I will take x less than 1. So as n tends to infinity, x power 2n will tend to 0. As you know, when you have p by limit n tends to infinity, p by q whole power n. If this fraction p by q is less than 1, then as the power tends to infinity, the value of the fraction will tend to 0. If it is greater than 1, then it will tend to infinity. Now I am talking about x less than 1, therefore x power 2n will tend to 0. So now I will consider infinitely many terms. 1 minus x into 1 plus x into 1 plus x square etc. up to infinity, infinitely many terms. That is equal to, what happens on RHS? As n tends to infinity, x to the power 2n will tend to 0. So we will have 1 on RHS. Okay? So from this we write that when x is less than 1, 1 minus x into 1 plus x into 1 plus x square etc. up to infinity can be written as, that is equal to 1. Okay? Now I will take log on both sides. Taking log on both sides. So when I take log, what will happen? Log 1 minus x, log 1 minus x plus log 1 plus x plus log 1 plus x square plus log 1 plus x power 4 and so on. On RHS we have log 1. Okay? So log 1 minus x plus log 1 plus x plus log 1 plus x square plus log 1 plus x power 4 and so on up to infinity is equal to, on RHS you have log 1. Now differentiate this. Differentiating with respect to x. Derivative of log 1 minus x is 1 by 1 minus x into the derivative of 1 minus x, which is minus 1, plus derivative of log 1 plus x is 1 by 1 plus x, plus the derivative of log 1 plus x square is 1 by 1 plus x square into 2x, plus 1 by 1 plus x power 4 into 4x cube and so on. On RHS log 1 is there, which is 0, and its derivative is also 0. Now see what you want. We want 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 etc. That is what we want. This is what we don't want. So you take this to RHS. Okay. So we will have 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 and so on up to infinity is equal to, I am taking this to RHS, we get 1 by 1 minus x, 1 by 1 minus x, which is the third option. Okay. Next, 47th question. If 3f of x minus 2 into f of 1 by x is equal to x, then f dash of 2 is equal to 3f of x minus 2 f of 1 by x equal to x. Then what is f dash of 2 they are asking. 3f of x minus 2 f of 1 by x equal to x. Before finding what is f dash of 2, we must know what is f of x. If I know what is f of x, then I can find out f dash of x and then f dash of 2. Here I will change x to 1 by x. Changing x to 1 by x in this equation, we get 3 into f of 1 by x minus 2 f of x is equal to 1 by x. Changing x to 1 by x. So 3 f of 1 by x minus 2 f of x is equal to 1 by x. Now you solve these two equations so that f of 1 by x, we should eliminate f of 1 by x from these two equations so that we get f of x. For that I will multiply this equation with 3 and this equation with 2. Okay. So when we multiply by that, we get a 9 f of x minus 6 f of 1 by x is equal to 3x. Here we get, here I am multiplying this equation with 2. So 6 f of 1 by x minus 4 f of x is equal to 2 by x. Now I will add these two equations. When I add this, that 6 f of 1 by x gets cancelled. I am adding these two equations, that will give you 5 f of x. 5 f of x is equal to 3x plus 2 by x. 3x plus 2 by x. So f of x is equal to 3 by 5 into x plus 2 by 5 into 1 by x. This is our f of x. Now we want f dash of 2. So first you find out f dash of x. Differentiating with respect to x, that will give you 3 by 5 plus 2 by 5 into the derivative of 1 by x, which is minus 1 by x square. Okay. We are asked to find out f dash of 2. Put x equal to 2 here. We get 3 by 5 plus 2 by 5 into minus 1 by 4. So 3 by 5 minus 2 gets cancelled, 1 by 10. Take LCM, 10 is the LCM. So 6 minus 1, 5 by 10, which is equal to 1 by 2. Second option is the correct answer. 48th question. Consider f of x is equal to x square by mod x if x not equal to 0 and 0 if x is equal to 0. Then f of x is discontinuous everywhere, f of x is continuous everywhere, f dash of x exists in open interval minus 1 to 1, f dash of x exists in open interval minus 2 to 2. So the given function is f of x is equal to x square by mod x, x square by mod x when x not equal to 0 and it is 0 when x is equal to 0. Here x not equal to 0 means there arises two cases. One is x less than 0, other one x greater than 0. When x less than 0, what will happen to mod x? When x less than 0, mod x is defined as minus x. Mod x is defined as minus x. Then you have x square by minus x, which is minus x. If x is less than 0. Then if x is greater than 0, if x is greater than 0, mod x will be equal to x, then x square by x will give you x. X if x is greater than 0 and 0 if x is equal to 0. This is our f of x, right? And what is this function? This function is nothing but f of x equal to mod x if you observe. Minus x if x negative, x if x is positive, 0 if x equal to 0. So this is nothing but f of x equal to mod x. You know, mod x is continuous everywhere and not differentiable at x equal to 0. So look at first option, f of x is discontinuous everywhere. That's not correct because it is continuous everywhere. So continuous everywhere is the right answer. And why this is not correct? F dash of x exists in open interval minus 1 to 1, they have said. and 0 belongs to that interval minus 1 to 1, but at 0 f dash of x does not exist. Hence, third option is not the right answer. And obviously, if f dash of x does not exist in open interval minus 1 to 1, then clearly it cannot exist in the open interval minus 2 to 2, because minus 1 to 1 is a subset of minus 2 to 2. Hence, second option is the correct answer. Okay, next question. 51. If f of x is equal to x divided by root of 1 minus x square and g of x is equal to x by root 1 plus x square, then the derivative of f circle g of x, f of g of x. Okay. Say f of x is equal to x by root of 1 minus x square, g of x is equal to x divided by root of 1 plus x square. First we shall find out what is f circle g of x. That's equal to f of g of x. That's equal to f of g of x. G of x is x divided by square root of 1 plus x square. Now we want f of x by root 1 plus x square. F of x is defined as x by root 1 minus x square. Now f of this expression, replace in this, wherever there is x, replace it by this factor. We get x by root of 1 plus x square divided by square root of 1 minus x square is there. So, it is a square, that is x square by 1 plus x square. Okay. This is equal to x by root 1 plus x square whole divided by, here what do we get? 1 plus x square is the LCM, 1 plus x square minus x square gets cancelled, root of 1 by 1 plus x square, that root 1 plus x square gets cancelled. So, you are left with x. So, f circle g of x is equal to x. Therefore, d by dx of f circle g of x, the derivative of x is equal to 1, which is the first option. Then, 53rd question. F of x is equal to root of 1 minus root of 1 minus x square. Then, f of x is equal to square root of 1 minus root of 1 minus x square. Then what is f of x? Continuous on, f of x is continuous on closed interval minus 1 to 1 and differentiable on open interval minus 1 to 1. Continuous on closed interval minus 1 to 1 and differentiable on minus 1 to 0, union 0 to 1. Continuous and differentiable on closed interval minus 1 to 1. Continuous and differentiable on open interval minus 1 to 1. Okay. So, here you observe that in all the options they have mentioned that it is continuous, right. Continuous is present in almost all the options. So, let us verify the differentiability. Okay. So, for that what I do is I will directly find out f dash of x and I will put some values there for x and check whether it exists or not. F dash of x, differentiate this. 1 by 2 root of 1 minus root of 1 minus x square into, now the derivative of 1 minus root 1 minus x square, that is minus 1 into 1 by 2 root 1 minus x square into the derivative 1 minus x square, which is minus 2x. Okay. So, 2 gets cancelled, minus into minus is plus. So, you get x by 2 into root of 1 minus root of 1 minus x square into root of 1 minus x square. Okay. So, this is our f dash of x. Now, let us check when it does not exist. So, clearly there is root 1 minus x square in the denominator, and when I put x equal to 1, I am getting 1 minus 1, which is 0. So, denominator is 0 means f dash of x does not exist at x equal to 1 and at x equal to minus 1. At x equal to 1 and at x equal to minus 1, different derivative does not exist. Therefore, third option is eliminated. Then, when this will be equal to 0, if I put x equal to 0, what happens here? You just observe. If I put x as 0, 1 minus 0, that is 1, root 1 is 1, 1 minus 1 is 0. So, denominator is 0 when x equal to 0. And not only denominator, numerator is also 0. 0 by 0 you get, right? Which is an indeterminate form, not defined. So, f dash of 0 also does not exist. F dash of 0 does not exist means function is not differentiable at x equal to 0. So, look at this option. This option contains, it says that differentiable on open interval minus 1 to 1. So, it is not differentiable at 0, hence this option is ruled out. And similarly, this option is also ruled out because they are saying that differentiable in the closed interval, open interval minus 1 to 1, and 0 is a member of this, where this function is not differentiable. Hence, second option is the correct answer. Observe that it is continuous on closed interval minus 1 to 1 and differentiable in the interval minus 1 to 0, union 0 to 1. That means 0 is excluded in that interval. Okay. So, second option is the right answer. Then 54th question. The function f of x is equal to x by 1 plus mod x is differentiable on, okay, differentiable on which interval? That is what we want. So, they have given the function, defined the function as f of x is equal to x divided by 1 plus mod x. So, when you have a function of this kind where you have p of x divided by q of x, one thing that we need to check here is when the denominator, when it will become 0. Denominator we have 1 plus mod x, 1 plus mod x will never become 0 because mod x is always positive. In the worst scenario, mod x is equal to 0, that is its least value. So, 1 plus mod x is never 0, okay. So, denominator will never become 0, fine. So, that problem is not there. Then the other thing that we need to take care, whenever we come across mod x, we need to test the differentiability at 0. Let us see what happens at 0. At 0 whether it is differentiable or not. Okay. So, for that I will consider two cases, when x is positive and when x is negative. When x is negative, mod x is defined as minus x. So, this function will be x by 1 minus x if x is less than 0. And if x is positive, mod x is defined as x, so the function will become x by 1 plus x if x is greater than 0 or equal to 0. At 0, this function is 0, f of 0 is 0, right, because here also you get 0 by 1, here also you get 0 by 1, both are equal to 0. This is our f of x. Now, everywhere else other than 0, everywhere else it is differentiable, no doubt. The only doubt that we have is at 0. 0 we are not sure whether it is differentiable or not, that we shall test now. Everywhere else it is obviously differentiable. Okay. At 0, how do we test? We directly differentiate. I have given you one shortcut. Directly differentiate this and put that value, put x equal to 0, right. So, that directly differentiating, I will write it in this form, x by minus x plus 1, because here I have one shortcut, ax plus b. If it is of the form ax plus b by cx plus d, then directly you can write its derivative as ad minus bc divided by cx plus d whole square. You know that formula, so I will write it in this form. Its derivative will be 1 minus 0, that is 1, divided by minus x plus 1 whole square. In other words, 1 by 1 minus x whole square if x is less than 0. Then if x is greater than 0, the function is defined as x by x plus 1. Now, if I differentiate this, we get 1 minus 0 divided by x plus 1 whole square, that is 1 by 1 plus x whole square if x is greater than 0. At 0, put x equal to 0 here in this, you will get the left hand derivative. Put x equal to 0 here, you will get a right hand derivative. Now, left hand derivative, put x equal to 0 here, we get 1. Left hand derivative is 1. And for right hand derivative, put x equal to 0 here, that is also 1. Left hand derivative is 1, right hand derivative is 1. Hence, the function is differentiable at x equal to 0. So, this suggests that this function is differentiable everywhere. So, everywhere means which option? Fourth option. Fourth option, that is all the above. It is the union of first, second and the third option. The union of these two will give us the set of all real numbers, right. Union of all the three will give you the set of all real numbers. 0 is also included. So, fourth option is the correct answer. Then 55. F of x is equal to x sin 1 by x for x not equal to 0. F of 0 is equal to 0. Then what happens? F is continuous at 0, f is differentiable at 0, f dash of 0 minus exists, but f dash of 0 plus does not exist, f is discontinuous at x equal to 0. Okay. So, function is defined like this, f of x equal to x sin 1 by x if x not equal to 0 and 0 if x equal to 0. Okay. The question is it continuous or not, is it differentiable or not? First we at 0 anyway, look at all the options we are talking about x equal to 0 only. At 0 we have to test its continuity and differentiability. So first I will test its continuity. Limit x tends to 0 f of x. Limit x tends to 0 f of x is equal to limit x tends to 0 f of x. In place of f of x I am writing x into sine 1 by x. You know its value, this is equal to 0 because this will be 0 and this will be a finite value between minus 1 and 1. So their product will be equal to 0. So limit x tends to 0, x into sine 1 by x equal to 0. What about f of 0? F of 0 is also equal to 0. So limit x tends to 0, f of x is equal to f of 0. Hence f of x is continuous at x equal to 0. Okay. F of x is continuous at 0. Then is it differentiable or not? That we shall test now. Okay. How to test the differentiability? F dash of 0, you know the formula. That is limit x tends to 0, f of x minus f of 0 divided by x minus 0. That's equal to limit x tends to 0, f of x. F of x is x sine 1 by x minus f of 0, that is 0, divided by x minus 0, which is x. So this x gets cancelled. You will have limit x tends to 0 sine 1 by x. This limit does not exist because we only know that it takes a finite value between minus 1 and 1, but we don't know what is its exact value, and therefore this limit does not exist. Therefore the function is not differentiable at 0. Okay, and third option is also not correct because neither the left hand derivative nor the right hand derivative exists. Okay, derivative does not exist. Therefore the answer is first option, f is continuous at x equal to 0. Okay, it's a very important result, remember this. Here I will explain one more problem along with this. Instead of x sine 1 by x, suppose if you have x square sine 1 by x, then what will happen? Here x square sine 1 by x, when x tends to 0, x square will also 0, so this is 0, hence function is continuous at x equal to 0. And what about differentiability? F of x will be x square sine 1 by x divided by x. Here one of those x gets cancelled, other x will remain. Limit x tends to 0, x sine 1 by x, so that is equal to 0. So instead of x into sine 1 by x, if it is x square into sine 1 by x, then it is continuous as well as differentiable. Remember this, this is a very important formula. Then 56th question. F of x is equal to x into e power 1 by x minus 1 divided by e power 1 by x plus 1 when x not equal to 0. Then r f dash of 0. R f dash of 0 means the right hand derivative of f at x equal to 0. So in other words, f dash of 0 plus it is. F dash of 0 plus, this is defined as limit x tends to 0 plus f of x minus f of 0 divided by x minus 0. That's equal to limit x tends to 0 plus x is approaching 0 from right side. So you can write it as x into e power 1 by x minus 1 minus f of 0, which is 0, divided by x minus 0 is x. X into e power 1 by x minus 1 divided by e power 1 by x plus 1 minus f of 0, which is 0, divided by x minus 0, that is x. X gets cancelled. You have limit x tends to 0 plus e power 1 by x minus 1 divided by e power 1 by x plus 1. Okay. Now if I directly apply the limit as x tends to 0 plus, x is approaching 0 from right side. When x approaches 0 from right side, what will happen to 1 by x? When x approaches 0 from right side, 1 by x will tend to plus infinity. And when x approaches 0 from left side, 1 by x will tend to minus infinity. Remember this. This is a graph of 1 by x. As x comes closer and closer to 0 from right side, 1 by x will tend to infinity. Look at 1 by x, you go on putting positive values for x. If I take x as 1, 1 by 1. If I take x as 1 by 2, then 1 by 1 by 2 it will become 2. If I put x as 0.1, then 1 by 0.1, that will be equal to 10. if I put x as 1 by 0.01, then 1 by x will become 100. So as x comes closer and closer to 0 from right side, 1 by x will tend to plus infinity, and when x comes closer and closer to 0 from left side, 1 by x will tend to minus infinity. Now it is tending to, x is tending to 0 from right side, so this will be infinity, this will also be infinity. So then it is like infinity minus 1, that is nothing but infinity by infinity form. You can either use L'Hospital's rule, or I will take e power 1 by x as common and cancel it. When I take e power 1 by x as common, here 1 will remain, here 1 by e power 1 by x. 1 by e power 1 by x divided by 1 plus 1 by e power 1 by x. We have taken e power 1 by x as common and we have cancelled it. So as x tends to 0 from right side, 1 by x will tend to infinity. So e power infinity will tend to infinity, and 1 by infinity it will become 0. This will be 0, this will also be 0. So the answer is 1 by 1, which is equal to 1, first option. So the right derivative is 1. If the question is left derivative would be minus 1, because when x approaches 0 from left side, e power 1 by x will tend to, when x approaches 0 from left side, 1 by x will tend to minus infinity. E power minus infinity you get. What is the value of e power minus infinity? E power minus infinity is 0. So e power minus infinity is 0, you get 0 minus 1 by 0 plus 1, that is minus 1 by 1, which is equal to minus 1. Then the left hand derivative at x equals 0 is minus 1, but here the question is right hand derivative, which is plus 1. Okay, let's have a look at this question. If f of x is equal to x power n cos 1 by x, if x not equal to 0, 0 if x equal to 0, and n greater than 0, then f of x is differentiable at x equal to 0 if. This is very similar to the problem which I explained earlier. Earlier I told you about x sin 1 by x. Now we have x power n cos 1 by x for x not equal to 0 and 0 if x is equal to 0. Okay, so this is differentiable that I have mentioned. Differentiable means we should have limit x tends to 0, f of x minus f of 0 divided by x minus 0. That's equal to limit x tends to 0, f of x. F of x is x power n cos 1 by x minus f of 0 is 0 divided by x minus 0. One of those x gets cancelled. So you will have limit x tends to 0, x to the power n minus 1 into cos of 1 by x. Okay, this limit should exist. Limit will exist if n minus 1 is greater than or equal to 1, right? Because if n minus 1 is 0, then what happens? If I say x power n minus 1, if I put n minus 1 is equal to 0, that means x power 0 you get, x power 0 is 1 into cos of 1 by x. So 1 cos of 1 by x you get, that limit does not exist. If I put n is equal to 2, then 2 minus 1 is 1, x into cos 1 by x, x into cos 1 by x, this limit is equal to 0. So that means n minus 1 should be greater than 0. N minus 1 should be greater than 0. That means n should be greater than 1. So greater than 1 means n belongs to open interval 1 to infinity. Okay, if it is not clear, you can go for trial and error, take some values from this, put n equal to 1. Put n equal to 1 means x power 0, that is 1. 1 into cos 1 by x, as x tends to 0, this limit does not exist. Therefore, function is not differentiable at 0. So if I take n as 1, so n as 1 will not work, right? Then if I take n as, these two options are ruled out, right? Then you take one value here. If I take x as 0.5, 0.5 minus 1, that is minus 0.5. X power minus 0.5, in other words x power minus 1 by 2, in other words 1 by root x. Then cos 1 by x by root x, that limit also does not exist, because as x tends to 0, root x, 1 by root x does not exist. Okay, hence the answer is fourth option. See, if they give you differentiable, then fourth option is correct. If they give you continuous, then this option is correct. This is applicable for x power n into cos 1 by x as well as x power n into sin 1 by x. N belongs to 0 to infinity if f of x is continuous and n belongs to 1 to infinity if f of x is differentiable. Okay? Okay, students, with this I'll stop today's class. We'll continue tomorrow. Thank you.